folks. Thought I'd do something a little different since this is our last lab together, as they say. For the calculations for this lab, I thought I'd share with you how you might do them on Excel, since I'm going to ask you to have charts created in Excel. I thought we could also use Excel to do some calculations for us. For those of you who already know how to do it, great, but for those of you who don't, this might be helpful information not only for this class, but for some other classes or other things you might do. Alright, so my webcam is here, and my work screen is there, so forgive me for looking off to the side here. Alright, so if I open this, which I posted on D2L, this is your instructions. In a couple of the sections I kind of jumped the gun and uploaded this before I added quite a bit of information. So it's been updated. Please recheck it. You have this information here. And then for everything, let's see, I got pea gravel and the 3/4 inch timed, as you'll see in the video if you look at it. Sorry, there's no sound. I don't know what happened. And then for the road pack specimens, you'll just use the total PSI. Okay, so here are the results in table format. So if I take this, and here are the calculations. It says to convert kilonewtons to pounds to PSI. The machine that we use records force in kilonewtons or kilograms, so that's why there's this conversion. So if we use Excel here, well, let's go back here for a second. 1 kilonewton equals 225 pounds, and compressive strength is the load in pounds divided by the cross-sectional area. So here's what we're going to do. We'll take Excel, and what I have here is a made-up specimen at 4 inches in diameter. The cylinder concrete specimens that we tested were 3 inches in diameter. I don't think there is a test specimen that's 4 inches, but for example purposes this will work. Alright, so first you have the formula for the area of a circle, which the cylinder cross-section is. So in this cell, I've entered equal sign, which in Excel you always proceed any formula calculation with equals to let the program know that you're wanting to calculate something. And it's pi asterisk for times the radius, which is half the diameter, with a caret 2, that means squared. Alright, so, and then for time in minutes, you'll notice that in the table it's every 15 seconds. Well, 15 seconds is a quarter of an hour, so you would enter, oops, and so on. And I'll go ahead and I'll pause the video and I'll fill this in. Okay, as you can see here, I've got everything filled in time. So then we have to come up with some kilonewtons. And we're just mocking this up, so I'm going to go, let's see here. Okay, so I'm going to go with just some random numbers. You, of course, get these from the chart that I have given you with the instructions for the lab report. All right, so we'll just do this. Oops, that should be 40.6. All right, so now we have time and the force in kilonewtons, which is exactly, of course, what you're going to see on your, oops, I touched my face, didn't I? Oops. On your charts that I filled out for you, or the tables that I filled out for you. All right, so if you remember the formula for kilonewtons to pounds, it's 225 pounds per kilonewton. So we want to go equals, as I said before. We're going to take this force in kilonewtons, that's cell C2, and we're going to multiply it, which is the asterisk, times 225. Hit enter, and that gives us our force in pounds. All right, so now we have a formula. In order to transfer that formula down to each one of these cells, Excel will automatically change C2 to 3, 4, 5, 6, 7, and so on. When I drag it down, you move the cursor to the lower right till that little cross appears. You pull it down, and it calculates everything for you. Okay, so we have the force in pounds, and in order, as the instructions showed, we now have to calculate the force in PSI, which is the force in pounds divided by the area of the cross section. So again, we take equals, and then we want to go D2 divided by our area, 12.56. We hit enter. And that's quite a few decimal points, so we're going to go up here to number. We'll pick number again. It's already set at 2, but you can set it to whatever. We're going to make it 2 and go OK. And that reduces our decimals down. Okay, so we have the formula in there. Again, we line up our cursor and pull it down. And there we have our PSI. All right, looks like the maximum PSI was 1,641 PSI, pounds per square inch. So now I'm going to require a chart for each one of these. So really, we no longer need this information, but we do need the time for the x-axis and the force for the y-axis on our chart. So what I'm going to do, I'm going to leave that highlighted, and I'm going to cut it. I'm going to move it over a couple here. I'm going to paste it. I'm going to cut this and paste it right next to it. You might remember doing this with the, I think we did it for tensile testing for brass, not brass, but for non-ferrous. So this is review here for most of us. Okay, so then I highlight those two columns, time on the left, force on the right, and I come up here and I click insert, recommended charts. And we'll pick this one. And we'll go OK. And then I'm going to make that bigger, make it easier to see. We will make the chart title fake sample 1. And we're going to go over here and we're going to hit the plus sign. And we're going to put axis titles in. And we'll do this one as force PSI. And this one as time minutes. Okay. And then I think we'll also add our data labels. And so there you have it. That's all there is to it. So Excel does make it quite a bit easier if you want to use it for that, for this type of thing. Again, of course, if you have any questions, text or email. This will be due Friday night. This was our last lab together. So before we part ways, I guess, I want to thank you all for being an attentive group of students. And I, want to express my regret that I think we all pretty much feel that we didn't get to enjoy spending the time together one-on-one, face-to-face, and you getting to perform these labs. I'm really sorry that circumstances arose like that. Life throws us some curves. Every generation has, it seems, some big challenge, and this is a big one. But as the British said in World War II, when the Nazis were bombing them, keep calm and carry on, and enjoy your summer. And let's hope and pray that everything returns to normal as much as possible. Our country gets back on its feet, and that I can see all your smiling faces in class next semester, or at least in the halls as we pass. Again, take care, and it's been a real pleasure.